Hello. So in this lesson we're going to be exploring the addition of ordinates, and specifically we're going to be looking at the addition of ordinates when we're dealing with circular functions. However, before we go into circular functions, I just want to go over the basic of addition of ordinates, and I want to explore it by having a look at two somewhat basic equations and then adding their coordinates together to be able to find a resultant graph. Okay, so we're going to start with our first function, and we're going to say that this function is given as fx equals x. Another way to write this would be just y equals x. Then we're going to have a look at a second function, so our second function, and we'll call this function gx, and we'll say that that's the square root of x. Now, the task for us at this point is to sketch both of these functions on the same graph and then add their coordinates together, specifically their y coordinates together, to find the resultant graph for the addition of ordinates. So let's start with just drawing up our axes. Okay, and now we're going to sketch fx. Now fx is a nice linear function, and it should be crossing all the way through. Okay, remember that it's just a sketch, it's not a portrait, so it doesn't have to be perfect, but we want it to be looking at least like the function. And this function is fx. And then we're going to sketch gx. Now gx is a root function, and gx will look something similar to that. Okay. Now, the idea of addition of ordinates is being able to ascertain what the coordinates or what specific coordinates are on both graphs fx and gx. So we're going to have a look at some specific coordinates firstly on fx. So obviously the intercept is really important. So 0, 0. We're also going to have another point here, 1, 1. That's very important. And I'm going to choose another point here, and I'm choosing this point specifically, and I'll talk about why I chose that point specifically, 4, 4. Now, if I go into the negative x region of this graph, I could have a random coordinate, -3, -3. That all makes sense. Now I want to be able to identify some coordinates that are happening within gx. So I have a coordinate here, 0, 0. I have a coordinate here, 1, 1. And I have a coordinate on gx, which is going to be 4, 2. Now the idea is that what we want to do when we're wanting to sketch, and we're going to say our addition of ordinates is hx equals fx plus gx. What we are wanting to do is to add the coordinates. Now, specifically the coordinates that we're adding are the y coordinates of each of these respective values of x. So if I have a look at this value here, but that won't be, well, it actually will be the coordinate, and I say, okay, for x equaling 0, I have y0 plus 0 here. That gives me 0, 0. That's our coordinate, and I'll do it really, really large, of hx. Then if I go to my next coordinate and I say 1 plus 1, so this is when x equaling 1. So when x equaling 1, we have 2. that's up here. And that will be 1, 2. That 2 comes from adding this coordinate and this coordinate together. That's where the 2 comes from. And then I want to have a look at 4. So when x equals 4, and I'm going to have 4 plus 2, 6. And I'm going to have a coordinate all the way up here. Okay. Remember, it is just a rough sketch. But when x equals 4 and I add the y coordinates together, I get 6. Now, obviously, because I don't have gx within this region, it means that I don't have hx within this region. That's really important for us to understand. So this graph, sorry, I'll just get the sketch a little bit better. Let's just make that there, because the graph will be curving out like so. And this is what we call hx, the addition of ordinates. And that's when we're dealing with two very simple equations. Now, the next task for us, when we're talking about addition of ordinates, is to consider two circular functions. And it doesn't have to be necessarily two circular functions. It could be a power function with a circular function. It could be an exponential with a circular function. It could be any two functions together. But the same principles apply. Now, what we're going to say is we're going to have our first function. And we're going to start with probably the most basic circular function that we can have, y equals sine x. And then we're going to have another function here, and we're going to say y equals 2 cos 2x. Now these are really important because the amplitudes are different between both functions, and the period is different between both functions. So just to put it in function notation, we might write it as fx equals sine x, and we might say gx equals 2 cos 2x. Now, understanding how to sketch these graphs is really important. So let's just sketch it over the domain of 0 to 2 pi. So that sort of helps us out a little bit. Okay. We don't have any translations in terms of horizontal translations or vertical translations, which sort of makes it nice for this type of example. But let's sketch y equals sine x, or fx. So obviously we have an amplitude of 1. We have a period of 2 pi. And our graph for sine x will look something like that. And that should be pi on 2, and that should be 3 pi on 2. Now when we're sketching gx, I made a mistake. I might need to take that back. Let's take it back. I hope you all picked up on that mistake. If it is a sine graph, it would be starting out here, like so. I think my brain was thinking about cos too much. Okay, but if we talk about a cos graph, the amplitude is different and the period is different here. So my period for the cos graph here, the amplitude is easy to find, is 2 pi on 2. Therefore, my period is pi. So what that means is that my graph is looking like that, and like so. And what I want to be able to do is I want to be able to zone in on maximum, minimums, x-intercepts to be able to find where hx is going to lie. Now we're going to say that hx equals fx plus gx, and I'm really going to focus on, if you like, points such as here, 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 here and here, 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 here. And here. The reason why I'm looking for maximum minimums is because they're easy to ascertain. So if I'm talking about, for example, if I'm talking about these two coordinates here, well, that's 0 plus 2. The y-coordinate here is 0. The y-coordinate here is 2. Therefore, I have hx being there. If I look at this point here and this point here, this is 0 plus this point. So I have hx looking like that. Here I have, in the next point, I have y and -2. Add them together, I get -1. It should be a -1. Here I have 0, 0, and whatever this point is going to be, okay, up here. So I have a point here. Here I have 0, and this point, there we have that, 0, and this point here. Here I have -1, -2. Therefore, that's going to give me a point which is around -3, and it's going to be all the way down there. Then I've got 0 and this point, that will be there, 0 and this point here. Now the idea is to zone in on these X markers, because that's the shape of hx. And it's pretty distorted, but you can get an idea of what hx might look like. Okay, so we can see, and I'll do it really, really bold so you can see it. It's quite messy. I mean, addition of ordinates is not, I mean, if we're using it by actually adding the y coordinates together, it's not actually a really neat process, but you do get the result regardless. Okay, but you'd want this red graph hx as your graph.